I've been told that if I walk away in the back, people have problems understanding me. I try to do better now, so you can still hear everything I say. All right, so yes, I'm gonna wait 2 more minutes before I start for other back. So what you should see now on your screen is my Twitter crawler tutorial. Let me full screen this. I hope the full screen works on this. Okay, thank you. Okay, all right. I'm wait 1 more minute. If there's any question that you want me to ask right now, we can do that in the remaining minute. So the next course, AI with PyTorch, will be covered by Kevin himself, and that is the block after the next block. So the next block in the schedule will be our first guest speaker, Ibrahim Haddad from Linux AI Foundation, and he will speak about open source AI. I highly recommend attending this talk as well. And then after that talk Kevin, you have the time in your head better than I do. Kevin will present this talk is at 2 p.m. Berlin time. Yes, Kevin will present an introduction. Okay, does this course earn badge on GitHub? Not that I know of. I do not even know LinkedIn. No, we do not award anything. I'm sorry, just knowledge. Okay, then the other question was, how frequently will these workshops be conducted? This is our very first workshop. Depending on how good the turnout will be, how much people like it, we will share an evaluation forum. We will might do another workshop, of course, if it's going well. Okay, then another question, is there any voice assistant that is GPT-3 based? So as far as I know, not yet, but that's probably just a matter of time. You can look at the link that I just shared that lists a lot of GPT-3 examples. And then, will there be a certificate? Yes, Marta already responded. And then not a question, how to learn fast programming at optimal level. Take my coding class. You can ask the other people. I mean, it's a basic introduction to Python. And if I'll do it again, I will happily announce it on all of our channels. But the best way to learn Python, I mean, it sounds not helpful, but it's using it. So take an example, take a problem, and start coding. Okay, so now, thank you that you consider it an interactive session. Thank you very much for the compliments, and let's dive right into the next session. All right, so we are now 68 people. I think that can still be improved. Maybe some other people will join. Again, if you feel like you like the workshop so far, feel free to share it with other people. Sorry, I cannot answer all of the question. Okay, you're looking for research topics. Please send me an email. I shared my email in the chat already. I can share it afterwards as well, and I will respond to that later. Let's get into the content for this second session. So, because we want to deal with a Twitter dataset, I quickly created a little tutorial of how you can do your own Twitter crawler to get your own Twitter data. Because the hands-on part about this workshop is that after this workshop, you have technically all of the tools that you need to get your own data, start your own data analysis, and start doing some basic NLP exercises. Depending on your level of Python, of course, but most of the code is written and commented and described in a way that it should be able for you to do some basic things with it. Okay, so now the Twitter crawler tutorial here is basically requires you to have three things. First, you should have a Twitter account. Second, you have to sign up as a Twitter developer. And thirdly, you have to generate access codes to connect. So first, create a Twitter account. This is really trivial, right? You just go to Twitter and sign up. And then you go to this webpage, developer.twitter.com, and then you apply for access. It might take a while depending on your account that you have, but it's free and everyone can get it as far as I know. And then lastly, once you have access to the developer code, you basically, in that interface, you navigate to apps, you navigate to keys and tokens, and you can generate your consumer, it's called consumer API keys. You'll generate a key, a secret key, an access token, and a secret access token. These are four things you will need. And then the Twitter crawling or the acquiring of data that I will be doing, I was doing it with the Python package called tweepy or tweepy. So it's a tweepy package, and you can just simply say import tweepy as TW. Here I did a bit of error handling that you probably won't need. And then you access your own consumer, your own secret key, your own access, the four things that I've just mentioned. And then you can just copy paste this authentication thing. And basically what it does is you're connecting Python with your Twitter account to access the live stream of Twitter through these four statements here. So what is happening in the code above, I'm also using a keyword here that says wait on rate limit true. And this is really important because Twitter has this policy that they do not give away all of their data at once, but you have a certain rate limit. So rate limit are divided into 15-minute intervals. That's why I have this nice Mr. Bean waiting here, because if you want to get data, most of the time you can crawl a certain number of tweets, 1,000, 2,000, 3,000 tweets, then you got to wait 15 minutes, and then you can continue crawling those tweets. So that's why crawling tweets is tedious, right? You kind of like wait and wait and wait, even though technically you could get all of the tweets in an instance, but of course you can do it if you pay for it. And this is all for free, the stuff that I'm showing you. So if you don't want to pay for it, you can kind of like just wait 15 minutes. And what tweepy does for you is, in fact, indeed, wait 15 minutes, right? If you would not wait, Twitter will just kick you out. So tweepy makes this easier for you. So now I have defined the following three steps: the days, the search word, and batch size. And basically what it means, if I specify the days, these are the days that I want to look at. And here's an interesting fact: you can only go back as 7 days in the past if you want to acquire new tweets. Right? You cannot go further in the past than 7 days. So if you want to have data from last month, that is technically not possible unless somebody has collected the tweet IDs. And with those tweet IDs, you can then retrieve those old tweets. But current new tweets, you can only acquire within a window of 7 days if you're not going to want to pay. And then you can specify search words. These are, for example, if you don't specify them, it just takes all of the tweets starting from the first minute or first second of that day. And if you are specifying keywords, it is starting as well on the first second of that day, but it is it's collecting only those tweets that contain at least one of the keywords. Here, I will explain why I have used coronavirus-related keywords in a second. You can also have Superman-related keywords or AI for people-related keywords, and then collect all of the tweets related to AI for people. And with the batch size, you're basically specifying how many tweets you collect. Maybe you start with a little sample, because if you start with like 50,000 tweets in the beginning, you might already exceed your limit and you have to wait 50 minutes, even though you just want to have a try. So here I've written a little bit of code, and people from the coding class should be able to understand this, and everyone has a bit of Python experience, right? So what I'm doing is now I'm creating a collection of just a dictionary, and then I'm iterating over all of my days in my list of days, and then I'm setting a start date and an end date, basically a window of the start and the second date, which keeps moving over all of my days, because the API wants me to specify a day since and a day until. And if I take 2 days, I can make sure that I'm collecting 25, which is my batch size, 25 tweets per day. And then lastly, this is the actual Tweepy query that you're going to perform. So this is going to query Twitter, and then it's going to store everything in, here I called it tweets. Now I'm just simply turning the tweets into a list of elements. And once that it's done, I'm going to print the collection that I've just acquired with the days. And it tells me that I started collecting for the first day 25 tweets collected for that specific date. Unfortunately, I cannot show you this code, and you cannot run this code immediately because of the issue of the consumer key. This is something you have to paste into the code in order to make that happen. Bear in mind usual mistakes. If you start collecting tweets, you cannot use the developer key immediately. It takes the time to validate. Second most common issue, you're collecting an empty list of tweets because you have specified a day that is beyond the 7-day limit, or a day in the future even, that sometimes happens. And now if we look at what I've collected, basically the thing that is returned from the query is in fact a JSON object, which is a data format, with a ton of information. By a ton, I really mean the number of retweets of every tweet, the number of likes, the coordinates, even the profile background image URL of that user that has tweeted, right? So you get a lot of unnecessary information, and this is stored in a list then of 25 elements. And now, if you want to make sense of it, I also have a little script here. And basically what it does, it is taking every tweet, it is looking, and now, because you're using Tweepy, every tweet object can be semantically assessed. So you can use tweet dot created at dot, and then I'm string formatting. I'm formatting this information into a date, because I know that at tweet created at, it stores the information of the time of creation. Same for tweet.user.id. I can retrieve the ID of the user. And I can get the, if let's say the user posts an image, then there will be a tweet.image.link or something like this. And then I can retrieve the link to the actual image. So JSON is like the most exhaustive list of information about a single tweet that you can get. Everything that has been posted, if it's an image, if it's a video, if it's a text, will be entailed in that JSON in one way or another, but it's only coming in a text format. If there's an image in it, it will be a link to that image. Okay, so now I've done a bit of processing here. So I've basically said, I've created a list of all of the user IDs, and I'm only going to collect the user, I'm only going to collect those tweets from users that I have not previously collected tweets from. Why? I will explain in a second. And now we can see an example. I've changed all of the numbers, so this is all fake data. So you can see first tweet collected at this time was this tweet, second tweet. So now this is basically information that you retrieve if you only store. And what is that I'm storing? I'm only storing a tweet created at and tweet full text. That's the only thing I'm storing. This contains the tweet and the user ID. So why am I getting rid of multiple users? Because scientific analysis of fake news in the 2016 US presidential election showed that about 1% of users accounted for 80% of fake news, and reported another research that suggested 80% of all tweets belong to the top 10% of tweeting users, which I like to call super tweeters, right? So let's say you want to investigate a phenomenon and you collect a lot of data, and then all of a sudden you have collected only the data from 10 people, even though you have 10,000 tweets, because those people have tweeted a lot. So for my linguistic analysis, at least, I'm only looking at single users. Of course, this is just a suggestion, and you can use those tweets in any fashion you want. If you want to do a geospatial analysis, of course, you're not interested maybe in the tweet, but you're interested in the location that is tagged in the JSON as well. there's really good documentation of 2EP of how to handle the input that you get. And now, once we have collected those tweets, I've now decided to store those tweets in the following format, just because I decided to do it. First, the date in the format year, month, date, or in that case, date, month, year, and then white space or tab, colon, 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 tab. I do this because this is really unique. It's very unlikely to appear in the data. We have a tab and the symbol. So this is my way of storing this data, and I've stored it in a file. So this is where we at this point. This is something you can reproduce yourself with your Twitter data. And let's now all assume you're at home, have created your own Twitter data, you want to investigate a certain phenomenon, and now you've created your Twitter data, and this leads us to the final topic modeling exercise of this, this tutorial, right? So I'm now opening a new Colab notebook. You can access the same. So GitHub, and I'm, oh no, a recent should be there, and I'm using my GitHub. I'll show it to you how it's done. Hopefully it's still in there. Yep. So we got the repository, and now I'm going to topic modeling. And this is loading. So, all right. Okay, so this is now the introduction to topic modeling. And what we are going to investigate is a data set that we have created in the last session. I've showed you, I have trained a GPT-2 language model and fine-tuned it on a corpus of tweets that I personally gathered for a research project. This is a bit of shameless self-advertisement. So beginning of this year, I wrote a paper on a project called Framing COVID-19, how we conceptualize and discuss the pandemic on Twitter. It's currently open access on the research archives. I've linked it here if you're interested, but again, this is just situate the corpus in the broader perspective. And what we've done there is we did topic analysis, topic modeling on a corpus of tweets of the first 2 weeks in March of the coronavirus outbreak, and did an analytic study of how metaphors are persuasive in this debate. Okay, I stop with my self-advertisement here. And this is just to situate where the initial corpus is coming from. So I've taken that corpus, I've fine-tuned a GPT, and I've generated basically a coronavirus tweet-related fake data set for you. And this fake data set can be accessed in the GitHub of AI for People. So it's stored at the workshop, and then NLP, and then GPT-2 Corona tweets. I'm going to click on this and showing it to you. I hope you can see this. It should be working full screen. So in NLP, I click on the tweets here. And if I click on raw, it should open those tweets. So these are all the tweets that GPT-2 has generated for us. So this is important to note that any sort of analysis that we are now doing is based on fake data. So if we are looking for any sort of phenomenon, this is just purely statistical nonsense, so to say. But it's a really good example, I think, to work on this. So how are we going to start this? And now I'm trying to be a bit more down to the code in this latter part of this tutorial. So I'll try to explain the code a bit more so you can actually follow along a bit better what's happening. Somebody muted me again. Whoever it is, please do not mute me. All right. Where did you lose me? Okay, it should be working, right? It should be working now. 30 seconds ago. Okay. All right. So now we'll be going in a bit more. Maybe it's just to see if you're still listening, right? No, I don't know. Somebody keeps muting me. Please don't do it. Yes. So the next thing that I'm going to do is showing you in a bit more detail the code. But again, at the same time, I cannot go into super super deep level of certain algorithms here, but I'm kind of like have to manage my way between people who are new to coding and people who want to know a bit more about NLP and come from coding. Anyway, so what we can do here is now I'm going to import a native library from Python called URL-lib. So the URL library, which allows me, so I'm specifying this link to the data set that I've just showed you, right? This is the link to the GitHub. And now I'm using URL and URL-lib to send a request to open, URL open, my data set address. And basically what it does, it just opens the text file that you've just seen in the GitHub in Python. And once that is done, I'm just going through this text file line by line, and I'm going to decode the file using UTF-8, which is basically just a text encoding format. And now I'm printing only the first 10 lines to show you what's in there and to really convince you that it's actually loading in there. So now the tricky part is I could run this code right now in front of you. Actually, why don't I do this? This cell should be fine. Okay. So this is now connecting to the Google server and running my code as we speak. So the only issue why I cannot do the whole session live is, there you go. That's why I don't do live coding. Yes, great. I have no clue why it is not working, but you've seen the tweets before. URL lib3. Just give me 1 second. Maybe I can. Yes, I was experimenting with URL lib3 before. I think it was URL lib3. And this doesn't have the URL open. One last attempt. Okay. I remember I was experimenting with this before, so that broke it. Yeah, it should be the right Python version, but sometimes, you know, you can never know. Maybe use curl. Yeah, okay. My bad. Let's just quickly, and this is what I meant. I've run this code 3 times yesterday to make sure it actually works. Okay, there's another suggestion from the chat. We're all programmers here. Give it one last try, but I don't really feel confident in in doing this. Okay, let's try. See if the chat saved. The chat saved me. Great thanks to the programmers. Okay, so it was an import mistake. These things happen. Okay, so the only thing why I can't and won't do live coding. So there's 10 extra points to the 3 people that suggested this solution. Yes, so the problem why I cannot run the entire notebook is because it includes learning, and the learning will take about 10 minutes, and I don't want you to be waiting. So I'm keeping this output open, and you can see here now it's taking the first 10 lines of the coronavirus fake data set. Next step is some data pre-processing. This is something most NLP researchers will spend a lot of time on. That is data pre-processing. So currently we have just simply taken all of the tweets from the language model. But the language model in itself isn't perfect in creating those tweets. So for example, it could create tweets with less than 3 characters, like AA, BO, or some weird characters. Also, it could generate tweets that only consist of mentions, like at blah, at bo, at blip, or something like this. Or tweets normally have not more than 240 characters, but GPT-2 might have generated tweets above that limit. So what we will do in this little script here now is I've created a dictionary to store my future data in. And now I'm going through each line of my data. And for each line, again, I'm decoding into UTF-8. And then I'm going to split now my data at this token that I have decided to put in, right? This is this token here. So now if I split this, I know that on the left-hand side of my split, I will receive the date, and on the right-hand side, I will receive my tweet. Now I'm also calling strip to strip away the line break at the end of each tweet. And now my three pre-processing steps here. First, if the length of my tweet is below 3, continue, which means do not store the tweet, just go with the next tweet. If And now I'm basically splitting my tweet on the white space and saying if every single word starts with an @ symbol, and this holds true for all of the words. This is a very convoluted if statement here, a bit of advanced Python. So if all of my elements in my sentence splitted start with an @ then I know it's only @ mentions, continue. And the last one, if the length of the tweet is more than 240 characters, get rid of it. And then after all of this is done, store my tweet in my data set at the corresponding date. So if I hadn't looked at the date before, create an empty list and append the tweet. If I already had a look at this date before, append the tweet at this date list. So now I have a dictionary with the first date, all of the tweets on that date, second date with all of the tweets on that date, and so forth. All right. Let's see. I feel adventurous. Let's run this and see if it works. Okay, so that worked. Okay. There's a longer question that I'm not going to answer now. And then, so what is the correct address to import? Yes, Kevin just posted it. I just missed the request. So now I've run this, I've pre-processed my data, and now I'm just going to show you by printing all of the items in the data set, and I'm printing the key and value. That is, in my case, the date and the tweets. But I don't want to print all of the tweets. I'm just simply printing the length of all of the stored tweets. So now I can see for each date how many tweets I've stored from my data set. And we get around 800 to 900 tweets per day for my entire data set. So now let's do some basic statistics on my data set. So in order to get a sense of what the data is we're dealing with, right, before we do some actual topic modeling, we kind of like want to make sure that the data we're dealing with, like let's say at least includes 1 or 2 topics that we have as a ground truth, that we know should be in the data. For sure, we know that the coronavirus debate is in that data set, because we know this was the search word that we've used to acquire the data, and then GPT do this. But it would also be nice, let's say I had this intuition, okay, what about we expect at least one of the key figures in American politics with the most credible background on science should be in their data. So that's why I've decided I want to investigate whether the term Fauci is present in the data set, and maybe we can observe some effects of that name over time, let's say, because maybe our data set also includes a progression over time. So what I do if I want to analyze this now is I've created a new dictionary, and now I go through my data set. For all the items in my data set, I know that the key is the date and the value is the tweets. For the date, I'm now just going to replace the year 2020. This is just cosmetics because I don't always need to include 2020. And now I'm initializing for every date, I set the counter of Fauci to 0. And now for every tweet in my tweets, if Fauci is in the tweet, now look, I say tweet.lower because I want to lowercase everything in case people have different ways of writing it. Or I'm also including Dr. Fauci in the tweet. So if either Fauci or Dr. Fauci is in my tweet, then increment my counter by 1 for that date. And then at the end, print these findings. So I run this now, and it returns the dictionary findings. Okay, great. So if I continue now, so now we have collected the number of tweets that Fauci mentioned on every day of our corpus. So now I want to visualize this to make this more accessible. But now here's a little disclaimer. You probably all have different experiences in Python, and visualization in Python is something, right? I mean, that's not something I want to teach you. I want to teach you NLP. Visualization is an important tool that you need all of the time. So if I'm showing you our visualizations, I've kind of like decided to opt for a better visualization, but I have now sacrificed explainability. So I will not be able to explain the exact code in detail to you, or I don't want to, I could. But now let's be more obvious about the data and how you plot it. As people already mentioned in the chat, Stack Overflow will help you plotting these stuff and a proper understanding of Python as well. So basically what I'm just doing, I'm using a bar plot and a bit of plot cosmetics to create this nice plot here. So this plot basically just shows over time on the x-axis, and on the y-axis it shows the tweets with Fauci's name in it. And basically this is the overview of tweets with Fauci's name in the corpus. And we can see that there are some mentions of his name, but they are like on the magnitude of like 3 mentions maximum per day. And we have about 800 tweets to 900 tweets per day. Okay, I'm not muted. Okay, I'm just sanity checking. Okay, so now let's do the counter argument and say like, okay, how about the president of the United States? So we take the exact same code and just create a new dictionary and exchange Fauci with Trump. And if we run this code now, and at the same time plot this into one graph, we can get a completely different distribution, right? We see that Trump largely outnumbers the mentions of Fauci. And remember, this is as a disclaimer again, this is just completely, it's not random data, but it's imagined data. So it's data, fictional data, that's the term. It's fictional data provided by GPT-2. All right, so any quick questions until that point? Okay, so the next would be some actual topic modeling algorithm applied on our data set. So the topic modeling algorithm, there's a few out there, but the one that I want to present is the latent Coherence. I practiced this before, but I forgot. The LDA, so the latent Coherence allocation algorithm that I want to use with you. The problem is now explaining LDA in profound detail would take me at least another 40 minutes, and there's good YouTube videos and good descriptive articles, which are some are more and some are less technical and abstract. So I've linked the two that I think are really good in understanding this algorithm. And the only thing that you need to take away now that I'm trying to explain is basically what LDA does. It is an unsupervised learning algorithm to create to identify topics in a set of documents. So basically what it means is that I have, let's say I have a corpus of documents, and I want to figure out what document belongs to which topic. Let's say I have a corpus, Wikipedia, and I'm assuming there's roughly 200 topics in this corpus. Then I can say, please LDA, model this corpus according to 200 unknown topics. I do not know which these topics are, but please sort this, basically please sort all of the documents into 200 buckets, okay? And then through statistical analysis of the occurrence of the words and the co-occurrences in different documents, the algorithm, I mean, this is just really the most basic explanation, will try to sort them into meaningful buckets. And then the human can come along and say, okay, these buckets look meaningful because there are documents in that seem to share the certain theme. And then the human can go ahead and infer the theme by looking at those documents. It could say, okay, this topic is probably about this. So there's a main issue with this algorithm is that it's that you have to specify the number of topics or the number of buckets you want the documents to be sorted into, right? Because in most of these cases, there is no underlying truth, right? There is no underlying truth of grouping documents into topics. Because if you look at Wikipedia, even the taxonomy in Wikipedia is inferred by humans, right? They decided, okay, we want to group this into politics, into science, and into whatever, but you could also group it into American politics and stuff like this. So the granularity in which you decide these buckets to exist is the number of topics, that I want to be identified by the algorithm. You can also call this clustering, right? So you're basically trying to identify clusters of topics within the data. And as Kevin pointed out, this is similar to k-means, right? So k-means is a famous machine learning clustering algorithm that basically does this. K-means, also you specify the k, the number of clusters that you want to identify in your data. Okay, so much for LDA. If you want to know more about the technicality behind it, these are the 2 links that I can recommend. Let me go full screen again. Okay, right. So about the statistical inference now. So here's a bit of advanced knowledge for everyone who really wants to dig into it. So when I first started doing it, I've started using the Jensen library. So the very first approach, I've told you, right, there are different libraries that you can use. This one that I'm going to show you uses the Jensen library. And in the Jensen library, the very vanilla version of the LDA algorithm in the Jensen library uses something called variational Bayes or variational online Bayes. And it's basically a learning method. Not going to go into deep detail, but it's basically variational Bayes methods are family of techniques for approximating intractable integrals arising during the training of the LDA model. What does it mean? So yeah, I've linked it here. I would lose half of the audience explaining it, probably myself in explaining it. And then a different method of doing the statistical inference is called Gibbs sampling. And it has been argued in the literature that Gibbs sampling is preferable over variational Bayes. So now I want to make the effort of not just using the vanilla Jensen LDA with you, but I am going to show you how to use the Gibbs sampling, a different flavor basically of the LDA algorithm. But all of the code that I show you, you can do the exact same thing using the standard LDA variational Bayes. You will get slightly different results that will vary in their quality. Okay, so make sure whatever LDA package you're using, make sure that you know what statistical inference method you're using, because this can affect your results. And also if you're doing this in research, you might attract criticism if you're using different algorithms. So for Jensen, I've linked the documentation here. You can find the LDA model being neatly explained, right? And I've linked the paper here that explains the online learning for LDA, which is the Bayes learning. And I've also linked the method of the Gibbs sampling. So what Gibbs sampling, as it does not come with Jensen per se, it's basically somebody wrote a bit of code that you need to import into Jensen. And the next few lines are provided by that person who wrote that code that says, hey, if you want to use Gibbs sampling, you can just use my code here and it'll install the Gibbs sampling for you. So this is what you see here now. I don't want to and can't really explain what's happening here. So it's installing this package, this wrapper for the Gibbs sampling. This is all, again, note that you can use the standard LDA model using LDA model, your corpus and your topics. And the thing we're using is just one word of a difference, but the underlying statistical analysis is slightly different. So now the whole thing is being installed here. That's a bit of a longer process. You just go to the next cell. So now after we've installed the wrapper, we can just import all of the necessary libraries for our LDA analysis and point towards the installed system that we just created. So now you can see the beauty of using the Colab. You can just dump all of the packages that you want, and most of them have already been installed on the Google server. So we're going to use Jensen, we're going to use NLTK, and later on we're also going to use XBlob. So now you can see I've imported Jensen, I've imported several tools from Jensen, and I will mention them throughout the lecture. And here, this is also just a bit of setup for the Gibbs sampling. I don't want to confuse you too much about the Gibbs sampling. Just think of it as using LDA, but with a bit of different statistics. I'm just going to switch on or off the different statistics, and you can do the same, either using this or not. All right, so now everything after the whole introduction to topic modeling, let's get to the real code. Let's look at what our data can give us. So what I'm doing now, I said earlier, what LDA does, it takes a set of documents and it can put them into buckets of topics, right? But since we don't really have a lot of documents, right? We're not looking at Wikipedia, but we're looking at tweets. So the trick that we're doing here is now we are considering every single tweet to be a single document, okay? So for this, I will have to, this is a basically, for those who don't know list comprehension in Python, this is a double for loop. Think of it as two for loops nested into one another. So I'm saying for my tweets in my data set, okay, take each of those tweets which were stored in a list of tweets and now extract every single tweet. This is just a very shorthand notation of saying from my date and list of tweets, date and list of tweets, date and list of tweets, take all of those tweets and just put them in one big document. So now documents, if I say this, number of documents in the corpus, now if I print the length of the documents, it says 25,749. So now my entire corpus is 25,749 individual tweets that I'm considering as documents. One document, I've just picked randomly document number 15. One document now looks like this, and we can see it's actually a tweet from the data. All right, so far so good. So now we have one huge document variable that contains all of our tweets. So now, again, as the pre-processing, okay, the question that has just been posted, but a tweet can have more than one topic. That is exactly right. And we will talk about this when we look at those topics. Good question. If you haven't understood it later when I explain it, please ask the question again. Okay, so another pre-processing step. So next we will define two functions that will help us for the pre-processing. Because if you're using LDA, the LDA algorithm will just pick up every word and do inferential statistics with it. But it would be much more advisable, since we know what data we are dealing with, to pre-process the data. So first of all, there's a lot of slang usage on Twitter. LOL, WTF, I don't know, stuff like this. That is, yes, it is semantically meaningful, but it's probably not semantically meaningful for our topic analysis, right? So there could be concatenations or repetitions of the same character, like LOOOOOOL, which is a word that has no semantical meaning for our analysis, or items like AA or FU or GG or something like this. So what we can do is we can create a stop word list, and the stop word list simply contains a very, very long list of words that we want to exclude from our data set. So I've also uploaded my stop word list here that I've built from two other stop word lists that other people built over time, right? These stop word lists just keep increasing. So I've shared the references here and I shared mine. And I can also just load it with the same URL request, right? And now I need to correct this, but I'm not going to run this code anyway. The risk of, I don't want to retrain my code, right? So later on we do some training and I don't want to infringe that. So now I'm basically going through my entire data set and I'm just going to, well, later on, so I'm creating my stop words. And now I also know that my entire data set is based on coronavirus, right? I've used all of these hashtags to gather this data. So they will be also in the data set, and I don't actually want the topic coronavirus in my data set because I already know it exists. So for that reason, I'm just going to update my stop words with specific terms about the coronavirus so that they will also be excluded from my analysis. Again, this is not how you have to do topic modeling. This is how I do topic modeling on my specific problem and question, right? Whether you want to keep those words, whether you want to insert certain stop words or not, is entirely up to your research. And it depends on what you're investigating. For example, if you really want to understand, for example, how the information about the coronavirus is spreading on Twitter, this is the wrong approach. Right? I'm saying this because if you want to do a media analysis, you have to look at the retweets, at the shares, at the likes, at the super users, and all of these things, right? Because this is actually how the information will propagate in the network. Again, there could be one person reaching thousands and maybe millions of people. Let's say the American president has one tweet. It will heavily influence the entire Twitter sphere. But we, in my specific example, were just interested in the underlying linguistic use of, in that case, it was metaphors of war. So in that case, I'm using these this type of pre-processing. Okay, this is just as a little disclaimer here. All right. So now I've implemented this pre-processing here, and yes, I'm also using Gensim, has a pre-processing stop words. So these are just additional stop words. Basically, I'm just getting rid of as many weird words that don't have semantical meaning as I can. And all right, so now we come to something called tokenization. The linguists among you might know what this is. So here I'm actually using a different package. Here I'm using the NLTK, the Natural Language Toolkit package. And you can find more on the source code definition here. So tokenization is basically what I said earlier. If you turn a sentence into a set of tokens, basically in this context, we can just call it the words, right? Or the single units of meaning. A dot is also a token. It's a unit of meaning, but mostly it's about words. So we're basically turning our tweets, our long tweet, into single units of words. It could also be an emoji is a single unit of meaning, a token, so to say. So then in the NLTK package, there is actually a so-called tweet tokenizer, right? This is a tokenizer specifically pre-processing Twitter slang. You can find, again, like more in the source code documentation. It is dealing with like mentions and hashtags and stuff like this in a more profound way. Right. So I just run the cell and it takes all my documents, it tokenizes all of my documents, and then I'm done. So if I look at a tokenized tweet, as an example, again, the same tweet that I had earlier, tweet 15, I can see now all of my words have been tokenized, right? So now they're all individual units here. Why is this useful? Because there are certain tokens, think about it statistically, there are certain tokens that will occur a lot of times, but are irrelevant for that token, for the topic itself, right? Let's say we have a text about American politics, then the name Trump might occur a lot of times, but the words House could appear also a lot of times. In the context of White House, it makes sense. But let's say the word, a really common English word, green also appears a lot of time. Then green isn't really as profound as the other words. So you kind of like, this is what the algorithm then inferentially does for you. It infers these dependencies that are relevant. So basically it's doing a bit of, it's called TF-IDF, term frequency and document frequency analysis. Okay, enough for that statistics before it's getting more complicated. So Gensim LDA works on the level of what's called bag of words. So bag of words now, just to cut this short, is basically creating a representation that is labeling all of those tokens, just in a very abstract way. So you can, again, you can read more about this here. So what I will do now is I will take all of my tweet tokens, I will do the pre-processing, that was the thing that I just discussed earlier, getting rid of all of the stop words, getting rid of all of the too short entries and all of these things. I'm also getting rid of every entry that has HTTP because you have this full in all of the data. And so after I got rid of all of those bad tokens, all of those bad units, I can also now filter extremes. That means, let's say I have tokens that appear an extreme amount of time. For example, the letter A, if I haven't filtered it out for some reason before, and it appears a gazillion times, that I know, okay, this is an outlier, just get rid of it. Or the other way around, if I have something that occurs only once, then I don't need to specify it, or I don't need to keep it, because if I have 5 million tokens, that's really not going to influence my topic model. Okay, now this is all of the pre-processing, and what I do now, after I've created a Gensim dictionary, which is basically this dictionary of tokens, I'm creating a bag of words from my pre-processed documents. Okay, how all of this fits together is not something that makes purely conceptual sense. It makes more sense because of Gensim, right? You will find and do the same thing or a similar thing in NLTK, in SpaCy, in the other language libraries, always a bit differently. the main key points are tokenization and bag of words. And they come together at some point to create your tokenized bag of word document that you can now here see as an example. Okay, so now I have treated my data to make it useful for my LDA algorithm, right? These are the steps that, at least in Gensim, you have to follow if you want to train your LDA model. They might be somewhat different. Of course, the syntax is different in scikit-learn or something like this. But this is one example of doing this. At some point, you will have to create your tokenized bag of words. All right, now we come to the training of the model. And I hope I didn't lose all of you. Still there. That's good to know. All right. So we can train now our LDA model provided the bag of words in the dictionary that we just created. So the topic algorithm, again, tries to identify topics within the corpora. So naturally, we have to define how many topics, right? I explained why, so now we need to specify how many topics do we want. So therefore, we just need to decide how many topics, right? And what you can do here now is, because you have the computational power, you can just say, well, why don't you create me a topic model for 1 topic, 2 topics, 3, 4, 5, up to 24 topics. And then we are going to investigate how good these topics are. And then we can identify how many topics would be the best model for our data. So there's a common thing that has to do with coherence, right? I'm trying to explain this more conceptually. Let's say you have a lot of data points and you try to put these data points into clusters, right? So you're seeing that there's a group of points that would neatly be one sum, right? You say, okay, this is a nice cluster and there's a nice cluster and here's a nice cluster. And there's a measure of measuring the internal coherence of those clusters. There's, in fact, a lot of different measures to measure this coherence. Basically, think of it as, so I've taken this, let's say I've taken 6 clusters, and I also have 24 clusters. And now I can evaluate the coherence, which could basically, let's think of it in a more, graspable way. Let's say you have built certain models, and you can investigate the stability of those models. How good, how coherent are these models in themselves? And there's a lot of math involved to figure those out. I've linked 2 articles that explain these measurements in more detail. But basically, on the top level, you're training a lot of LDA models. You're going to use a coherence model to assess how coherent those models are. And this is the part that if you run this code, it might take you up to 10 to 20 minutes, because now we have trained 24 models on our data, right? So now I've done that before, and now we can visualize the coherence. So what you can see now, the most important part of this code is, I'm creating a dictionary for all of the coherence values. I'm creating a dictionary for all of my models. Now, for all of the number of topics, 1 to 25, I'm basically printing, okay, what is it you're currently doing? I'm currently doing topic number 1. Now I'm calling Gensim models. And now, instead of just saying LDA model, I'm using the wrapper for the LDA mallet, which is using Gibbs sampling, right? You could do the exact same thing using gensim.lda model. But now I'm using gensim model wrapper LDA mallet just in order to access the Gibbs sampling, right? The difference between using Gibbs sampling and not using it is just basically the statement. The rest of the evaluation will be sort of the same. And we can also turn this mallet model that I've created, Gibbs sample model, into just a regular LDA model and use it. This is just during the training that we have to kind of like switch on or off this wrapper, which is what I'm doing here now. So I have a question in the chat. What is the processing limit of the Google Colab server regarding the number of topics? Good question. 24 topics did not kill it. So you can see up here we have RAM. And basically the difference is that it's just going to be very, very slow because it's not really optimized on RAM, at least the GenSim that I was using. And you can see here this statement saying workers, and workers basically ask for you to insert how many CPUs you have. So if I have 16 cores on my machine, I can say 16. But I didn't know how many cores I was using here, and it didn't really give it away, so I just said 2, right? And with 2 workers running 24 topics, I used a third of the RAM, and it took about 5 minutes for one of the models, for the biggest of the models. I mean, you can go crazy on this. I don't know, but you have to also bear in mind what's the trade-off here. Why I'm taking 24 and not 200 is simply think about it. If you were to have, let's say, 200 documents, exactly, that's the point overfitting. Let's say you have 200 documents and you end up with 200 topics, then all of the documents fall into one topic. That's a perfect fit, but you're not gaining any insight from this because you already know, okay, I'm looking at topic 1, document 1. So what we will do now in order to assess this, we will look at this coherence score. So I've also created a coherence model, which this comes from GenSim, and I'm just throwing my model into the coherence model, and I'm specifying I want the CV coherence model. Again, earlier I mentioned there are different coherence measures. I've decided to use the CV measure. And now I'm basically using the coherence model, putting in my just created model, my text and my dictionary again, because it needs this. And then I specify the coherence that I want to measure. And that measurement, I can say get coherence, I'm going to store in my list of coherences. So once all of this is done, once I've run through all of those models, and actually, because you've been asking about computing power, it takes almost as much time to get the coherence value as it takes to run the model, which I found odd. But apparently, doing the coherence means doing a lot of inferences within the model. So now we can visualize the coherence, and this is the interesting part. Now we can see this beautiful graph here. Again, I'm not going into detail about visualizing this. I'm just using a plot, and I'm plotting all my models, the length of my models. So I have 24, so I'm plotting 24 on the x-axis for all of the number of topics, and on the y-axis, I'm plotting the coherence. So I've stored them in the coherence CV, and this just gives me this nice plot. And what we can observe now here, and this is why I do not want to run this live, because the trick or the crux about LDA is if you will run this on your Google server, on your instance, your curve will look different because the inference will involve randomness, right? So your curve will look different, but it will follow the same trajectory, right? So maybe that bump is the bump that I have at 6 topics will be at 8 topics. They will still sort of like follow the same shape, no shame involved. And then what we can observe now here, a peak at topic size 12, right? We can see here where I have the cursor. I don't know if you can see my cursor. I'm just assuming you can see my cursor. Kevin, just confirm. Thank you. So you can see the cursor. So at topic size 12, we have our first spike. Oh, this is even 13. And then we have an increased coherence until like 21. But what we can see here, it's sort of like converging. And this is the point of overfitting. And what people do here now use is what's called the elbow method, because you're identifying at what point of the curve you're sort of like elbowing, at what point you don't have any strong increase anymore. I'm not making this up. I linked the elbow method Wikipedia article here, so you can look at it. And this is honestly like the best sort of assessment you can do. But the problem here now is with you don't just simply get the best topic number out of this method. It also is important to understand that this involves you to interpret what you're after, right? Again, you can, if you want to have a very fine granular topic distinction, you probably end up choosing 16 topics. If you want a more broader general topics, you can also opt for the first topic increase where it's going down. So in that case, we can see, I mean, apart from topic number 1, which is useless, we can see that there's always an increase until we reach 6 topics. After 6 topics, for the first time, we have a decrease. So you could say, okay, I want 6 topics. But you could also say, okay, I want here the 16 topics, for example, as the elbow in the curve. And right, so what's now really important is that you are storing your models, because as soon as this instance shuts down after 12 hours by Google Colab, or you close your browser or something bad happens, you're going to lose the models that you've trained. So now I'm just quickly showing you that we're actually dealing with just simple Jensen models. So I can call this function called Jensen models wrappers, LDA mallet model to LDA model. So I'm transforming my mallet model using sampling into a regular Jensen model. It still has used Gibbs sampling in its statistical inference, but now you can use all of the regular Jensen functions now on this Jensen model if you have turned it around. So now I'm storing my 6 topic model in model 6 variable, my 16 topic model in model 16 variable, and 24 in model 24. And now I'm using a Python package called pickle to store my okay, so now I'm storing my pickle. So I can simply just say pickle is very easy to use. To say import pickle, and then you can say pickle.dump, and you specify what you want to dump. It could be anything. It could be a variable, it could be a dictionary, it could be a list, it could be a string, and it can even be an LDA model. And then I'm specifying where I want to store it. So now I'm just storing it in this file. I just called it LDA6.pickle. You can also call it file 1 or whatever. So now we are dumping those 3 models because we're interested in them. As I said earlier, I'm choosing 6 because it's more broader, and also this one degree, we're choosing 16 because this is sort of like the highest we get in sort of elbow. And then afterwards we get confidence. I'm choosing 24 because why not? Because it's the most amount of topics that we have. Again, this also depends on your research question. And now after I've stored them, I can download them from my instance. So I can click here, and then they would appear here. They would be stored here, and then I can right-click. Let's just look at this right-click, and I can say, well, this is a sample data that comes with all of you should have those. And I can click download, and then I can download my model. In the same way, I can click here again later. Loading the relevant models works the other way around. So now I'm saying, okay, opening your LDA model, I'm specifying the path, and I'm saying pickle.load the file, and I'm storing them in variables again. And now I have opened my LDA model with 6, 16, and 8. So now you've done your topic modeling using LDA. So far, so good, but you've only done the training. We haven't done the fun part that is actually inspecting those topics. Okay, just a little read in the chat. Please also make sure all of Jupyter notebooks are linked, available to download. That is the plan, and they should be currently all available in our GitHub. Thanks, Kevin, for pointing that out. Okay, so now we have a first look at our topics. I can see that we have lost about 24 people since the start of the lecture. I hope it's because of the good weather and not because I'm losing all of the people because it's getting more technical. Anyway, so we can have now a look at, so what I'm doing is I'm selecting one of my models and I'm printing topics. So this is a function that comes from Jensen. I say model 6, print topics, and I'm specifying the number of words that I want to see in the topic. And arbitrarily decided it show me 8 words. So now it prints me for that first model, right? We can see here now for the first model, those 6 topics and the words. And the words now come with the weight, or so to say, the importance of that word for the topic. So for the first topic, India, the word India has the highest importance for that topic. And now for the second one, it's virus, and so forth. So we get these nice lists of all of the topics for 6, and then we have the same for 16, and we have the same for 24. It's a super long list. So now it would be ideal if we were to just represent this in a nicer fashion, because frankly, I cannot infer anything from this list of numbers and words. So we now look at the first form of visualization. Here now again, you can visualize it the way you want. I don't want to spend an awful lot of time in explaining visualization. I rather want to talk about what we can see. So now just bear with me here and accept that there is a package out there called Word Cloud, and Word Cloud actually works with GenSim, so I can just throw in my topics into the Word Cloud, and what I get out of this is this nice, these 6 nice Word Cloud topics. And here, ideally, if we look at the code again, Word Cloud also allows me, so I say cloud.generate from frequencies my topic words, and then I can specify the font size as well. What it does now, it generates from the frequency of those words. So what it does here, as you can see, the size of the word actually means the importance of that word in that topic. So now you can see they're labeled topic 1, 2, 3, 4, 5, 6, and it's up to the human now to make sense of this. Bear in mind, this is still fictional data, and when I did this, I was really surprised of seeing that GPT-2, the language model, has obviously did not make a nonsense, right? So we can actually infer some of those topics here. And again, take this with a grain of salt. This is just me looking at the data and being like, okay, topic 1 seems to be allowed lockdown in countries. We have lockdown, crisis care, India, China. So I just named it lockdown in countries, population, Pakistan, Indian, like this. And then topic 2, I had like virus and a lot of swear words. So I called it virus and cursing. The third one was like President Trump, House, real Donald Trump, America. I called this American politics. The fourth one, and so forth. I mean, you get the idea. You're basically inferring by yourself these sort of like broad topics, right? Just as a sort of like overall general topics. And you also don't need to do this. You can also just leave it to the observer to figure out the topics by themselves. But here's the catch. If you retrain your model, these topics should be definitely different, but they should also be somewhat similar. Meaning it will not be the exact same words in the exact same size, in the exact same order, but they roughly should compose the same clusters, right? You should roughly always have a Trumpian president American cluster. You should always also have, right? So this is the part where it gets a bit interpretive. But if, yeah, and also they will also definitely be different in the order. So topic 3 might be topic 1. All right, so the second visualization I want to talk about, actually, when I was trying to visualize this, I looked at, I went to Google and I said, okay, how do I visualize LDA using Python? And then there was a package called Python LDA visualization, right, as those things happen. So this package you can install using, so pip install, and then you say py LDA viz, so py LDA visualization. There's a whole paper written about the algorithm behind this. And right, be careful, this is a bit computationally expensive, because what it does, it's just basically inferring all of the possible states in that system to generate this. So, and I don't want to bore you with more details on this. Basically, all you need to do then is say py LDA visualization, GenSim, because we want to talk about a GenSim model, prepare, and then it prepares a file for you. You enter your model, your bag of words, your dictionary. This is some sort of like, you can decide what sort of inference you want to do. You can also leave that blank if you want. And then I'm going to save the output of this as an HTML file. And I do this for the 16 and the 24 model. You can see, practically, this is 2 lines of code to create a visualization. And this is the visualization that comes out of it. So I can load this file using HTML. So it's a HTML file, and then I load the HTML. And this is this really, really cool, I mean, for me, it's really, really cool, visualization of the topics. So now we can actually interactively click on the topics. And now we actually come back to the question raised earlier. Can a certain tweet have multiple topics? Yes and no, because we are actually working on a word level, right? So our clusters are composed of words. So I can now look at even, let's say, a single word, and that I can see now how, for example, the word time appears mostly in cluster 12, but also I can click on it in 12 and 3. So now I can look at cluster 3. Of course, time is really overrepresented. And then 3, which it isn't. It's further down the line, right? And interestingly, we can observe, for example, okay, let's do the more fun one, the 24 one, because now we can get a really fine-grained analysis. If I look, for example, at 15, what you can see here is country open, lives save police matter true black. And we can guess what sort of societal phenomenon has been captured in this topic, right? I would argue it has to do with the Black Lives Matter movement, right? We can get like protests, California movements, and so on. And if I look at the opposite, and this is really cool because the visualization on the left-hand side is a PCA, a principal component analysis. So it basically also means it's reducing the dimensions of these 15 topics to a plane of 2, which, to put this short, means the further away they are in this visualization, theoretically, the further away the topics are. So 15 and 14 should be on the opposite sides, right? And here we can investigate, like you can go crazy on this and investigate lots of different topics on this. And then you can pick, I don't know, what was it? You can also see, okay, 15, I click on this, and let's say we want to investigate police matter, like lives is probably in there as well. Lives, yeah. And then we can see it's mostly topic 15. We can take a different topic in India, is only in this topic as it seems, and we have like Indian government, Moody, and then I guess that's references to Indian politicians, right? This is also occurring in topic 6, and then we can look at topic 6, and now, as I said, it's referring to politicians. We see this is relating to government, states, and so forth, policy, right? So I think this is a really nice way of exploring your topic modeling. All right, so far so good. Let's look at inferring topic for new data. So what you can do now is, and this is where we talk about, can a tweet have multiple topics? Let's say your model is basically also a prediction model, right? So your model has now an understanding of those topics. And now you can use this topic model, and you can take a new tweet. So I have created a fake tweet where I know sort of that it has to be in one of those topics. So I've created a tweet that simply reads Trump USA, POTUS America, President American. And now I'm taking this tweet and I'm turning it again into a tokenization, which is what I have to do if I want to work with it. And then I'm showing this unseen document, this unseen tweet, to my model. And this gives me a vector in return. A vector of values saying what topic it is most likely to fall into this tweet. Now I'm just visualizing this vector, and what I can see now in this visualization, so on the y-axis we see the probability to belong to a certain topic, and on the x-axis we see the topic number. And interestingly, we see that for all of the topics except for 1 and 6, it has an equal probability to fall into one of those topics, which translates to it doesn't really fit into any of those topics because it has the same probability, basically a coin flip, except for topic 1 and 6. And now we know we can go to 12 topics and look at 1 and 6. And we immediately see those are the topics about pandemic, America, American, Trump, people, president, which makes perfect sense. So now we can see that our model works to some degree. And you can also do this with other tweets or new comments. All right, so now we come to the last bit, which is sentiment analysis. Okay, before I I continue. So somebody posted they're using a different package. Okay. Thank you for sharing this. Okay, we go to sentiment analysis now. So sentiment analysis is basically training a classifier to identify sentiment from text, whether a text can be positive or negative. And the sentiment analysis that we are using is not only looking at the dimension of negativity and positivity, so whether a tweet is cool, positive, or bad, negative. We're also looking at objectivity and subjectivity. So whether a tweet is a bit more like fact-based or opinion-based. And for this, I'm using the text blob library, which is a library for simplified language processing. Right? There are many, many ways of doing this. Some work better on different corpora, and text blob has been used by other researchers on Twitter. So that's why I decided, okay, let's use text blob, so that people have used it. And it's actually based on, so the sentiment analysis of text blob. You can do a lot of things with text blob, not only sentiment analysis, but the part of sentiment analysis stems from the pattern library, which I already mentioned earlier. And I've given the references here. So now let's look at the topic sentiment, because this is actually more interesting, right? I want to connect what we've done earlier with the topics with the tweets. And now this is probably the most advanced, but also the last thing we'll be doing. So I thought it's probably more interesting to see the sentiment of the topics that we have and not just an individual tweet. So what I will do now is I get a list of the 5 most important words for each topic, and I check which tweets falls into which topic by checking for those words. Again, right, a tweet then can fall into multiple topics. And then I check the sentiment for the tweet of this topic. So, right, without further ado, so I'm going through my model and I'm going to print all of the most important 5 words. That's the thing that I've showed you earlier. It's really long text. And I'm just going to extract the words. Right? This is just extracting the words. So going back to this here, I'm now just have written a few lines of code that just going to extract the words from the topic modeling. And this gives me this list. So for all of the 12 topics, I'm getting now the 5 most important words. And now in the next line, I've created a dictionary that is basically going to store all of my tweets that fall into one of these topics. And how am I going to do this? I'm going through all of the tweets and I'm building the intersection of the tweet and my current word list. So these are my 12 word lists, and I'm taking a word list and look at the intersection of the tweet and the word list, and I'm counting the intersection. So a tweet could have 3 words that also are important for topic 2, 3 words that are also important for topic 4, 1 word that's also important for topic 6, and 20 words important for topic 11. And then I'm deciding, just me, by my academic freedom, I want to take the one that has the most overlap, right? There's heuristics, you can do it otherwise, of course. And now I'm basically counting those. And this is just counting them over all of the tweets and a bit of formatting to present to you that for topic 0, I have now said 1,200 tweets have the highest, share the highest amount of words with topic 0. Does that make sense? Can somebody confirm in the chat? Do you understand what these numbers mean? So topic 9, now there are 800 tweets that share the most words with topic 9. And for 15,000 tweets, we have not decided because they did not share enough tweets with the, did not share enough tweets with this. And yes, Hannes rightfully pointed out, the pattern library has been initially trained on customer reviews. And I was really skeptical because customer reviews aren't really tweets, right? Aren't they? But a lot of other people have confirmed this in research. So I'm just blindly trusting those researchers. And I was really trying to find a good sentiment analysis tool for Twitter that just allows me to use it like this. But most of the thing that was out there was you have to train it yourself. So I've been using this, and this is rightful criticism. There can be a bias. And now, because we're sort of running out of time, what I've done here now is I have evaluated, because I want to be statistically sound, I have taken a random sample of those tweets that I found in the topic, right? I've taken 300 random tweets that I've assigned to each topic, and I've evaluated the sentiment and the polarity. Here you can see 4 tweets in my random sample of tweets, sample size being 300. Please evaluate the polarity. So I'm using blob, which is how text blob objects are being built. So I'm saying blob.sentiment.polarity, which is the polarity of that tweet, and blob.sentiment.subjectivity, which gives me the subjectivity. And then I've averaged those for all of the 300 tweets in each topic. And this looks like this, right? I have to skip a bit because I want to leave a bit more time for questions. So now I have created the average polarity of 300 tweets for the first topic, the average polarity of tweets for the second topic, and so forth. And I did the same for subjectivity. And here the values mean -1, very negative, +1, very positive. And for subjectivity, 0 means fact-based objective, and +1 means opinion-based subjective. And now finally we do a visualization, and I think this is really nice. So this is an overview of the average polarity of each topic, and basically what this allows us to do is say, okay, we can see that topic 0 is a bit more negative, and topic 5 is also a bit more negative. And yeah, if we look at what the most important words are, real Donald Trump, pandemic, and shit, and topic 5 is Trump, people, and president, so they seem to be a bit more negative. And the most positive one is the one, topic 3, or yeah, topic 3, news, thing, and grade, right? And then you can do your interpretations. I've you know, a bit of inference here, and I said, okay, we can see topic 0 and 5 are more negative, and 3 and 9 are more positive, right? And then if I do the same visualization for the subjectivity, we can interestingly identify that topics 3 and 5 are the most subjective, which makes perfect sense because 3 and 5 are also the most positive and the most negative. And now this seems to be confirming the heuristics in itself, because we can assume that tweets that are much more polarized, much more positive or negative, also tend to be much more opinion-based rather than fact-based. All right, and as a conclusion now, at this point I also wanted to start with the analysis, because bear in mind this is purely fictional data, so we might discover things that aren't really existing, right? This is just a GPT-2 generated argument, right? There's no research you can get out of this except for doing NLP for NLP's sake. So I hope you enjoyed this, and I've shown you a lot of different libraries and a lot of different stuff. And we have 4 more minutes that I want to spend on one last slide, because I know some of you might just tune in for this course and not for the others. I can highly recommend joining for the entire workshop if you can make it. So next up we have our guest speaker, and yes, this is just the little bit of self-advertising. If you really like this workshop, if you really like this the slide, there's different ways to help us, because we want to do this in future. You can either just level 1, you know, let's give us a like, follow us on LinkedIn, add me as a connection, and you know, stay tuned, join our Slack channel, talk about us. I will let you know about the course participation, and then you can post it on all of your socials and say that you really enjoyed this, right? And if you feel really adventurous, you can also, you know, we have like a few things that we need to pay for, so if you really feel like you want to help us out on this one, you can also donate. And now I have 3 minutes for questions. I will also extend this a bit more and stay longer. If there are any pressing questions that I didn't answer. First question, can we use PayPal for donations? I think so. I must admit I haven't donated myself, so, but it should be fine to use PayPal. Okay. Okay, I will also stop the recording, but I will still stay online to answer a few questions. Okay, I'm stopping the recording now.